Hello and welcome to Information Technology Video Developer Network. My name is Abdurrashid Hamid. I'm a certified Microsoft specialist working for Cyber Bionic Systematics. The topic of our lesson today is arrays. We're going to take a look at the different type of arrays, how to create arrays using different methods, and of course, one-dimensional, two-dimensional, three-dimensional, four-dimensional arrays. So let's start our lesson and get down to business. So the first thing we're going to look at is the meaning of arrays itself. What is the meaning of an array? What is an array? Well, this is very simple. An array is a named set of one-typed variables located in the memory adjacent to each other, which are accessed by their index. Now, what does this mean? This simply means that we have a set of one-typed variables. So, for example, let's say this is a variable. Okay, it's not a variable because we have the array sign here. If you have this double square brackets, it means it's an array, but we'll come to that. So if it's a variable, we have 1, 2, 3 type of variables, but this is not a variable. These 3 bytes that we have here, all together they are called an array because number one, they are all of the same type, byte type. Okay, number two, they have one name, array. So this is an array. It's like having 3 or 10 or 15 bytes all having the same name, but you access them using their index. Okay, you access them using one name, but each of them has its individual index. So here we can see that this byte is number 864. This is its address, okay? But we don't need this address. What we need to do is just to type array and have this open and close squared brackets and then write the index right in here. What is an index? Remember I told you that a computer starts counting from 0. So 0, 1, 2, 3, 4, 5, and so on and so forth. So the computer always starts with 0 here. Here we have 3 elements, 1, 2, 3. But take note that in numbering them, the computer starts numbering from 0, which is element 1, 1, element 2, and 2, element 3. Okay? So how do we ask the computer to create an array with 3 elements? Where do we specify these 3? We specify these 3 right here. You can see open and closed square brackets, and we have 3 inside. Now, this is where we specify the number of elements we want in our array. Okay, now this is the type of elements that we have. They are of byte type. And then you have this spatial open and close square brackets. This shows that this is an array, byte typed array. Okay, then here of course you can have a different name. You don't have to name it array, but we named it array. Okay, and then this array has 3 elements. What are these 3 elements? These 3 elements are bytes, 3 bytes. Each of them has the same name, array, 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 but they have different indexes. This is array 0, array 1, array 2. Okay, so if I were to tell you, like, let's say for example here, let's say right here we have our array. Okay, now this array consists of 3 elements, element 1, element 2, element 3. All right, let's take a look at this. This element is here, this element is also here, and this element is also here. So we have 3, 1, 2, 3. Now we have an array with 3 elements. And notice that we have here byte, and here we have byte 2. So this is the type of array that we have, type of elements, and also here the type. So you must specify a type that you want. If, for example, here we have int and here byte, it won't work. They have to be of the same type. They have to somehow be the same. Of course, you can have short here and short here. You can have int here and int here. It doesn't matter. What matters is you have to have the same type. Now, here we have byte. So meaning we have 1 byte here. If we had short here, what do you think will happen? Short has 2 bytes. So each one of these indexes will have 2 bytes. So for example, we'll have this, we'll have this and this. There will be 1, this 2. But we'll look at that very soon. So what we're going to do now is I'm going to show you how to create a different type, okay? This is how to create a type of array, an array index. We're looking at the indexing now and naming each part so that everybody will know what we're talking about. An array index is an integer or a value of type converted to integer indicating a specific element of an array. What does it mean it's an integer or value of type? Well, we mean that indexes here have to be 0, 1, 2, 3, 4, 5, so they are whole numbers, or a type of number that we can convert into whole numbers. And what is a whole number? You know that a whole number is an integer. So here we have whole number is an integer. So here are the indexes. The computer starts from 0, 1, 2, 3, 4, and so on and so forth. Then we have element of array. The element of array is this: first element, second element, and third element. Of course, we have 3 elements here because we have number 3 written right here. So since we have number 3 here, we have 1 element, 2, and of course 3 elements. Now, what's the value of the first element? The value of the first element is 10. The value of the second element is 0 right now, but we can assign a value to it later on. Then third element also has a value of 0. Okay, now let's take this out. Byte is the type of our array, and this means that this is a single array. If you have a 2-dimensional array, you'll see that we have a comma here. But right now, there is nothing inside these double square brackets, so it means it's a single type array or 1-dimensional array. The name of the array can vary. You can have anything. Well, now you might be asking yourself, what's the meaning of this new? Well, new, we'll look at it in our next course. It's a little bit complicated, but just to tell you a little information about new, this is like a zone, it's like an area, a heap of memory where we want this array to be created and allocated 3 bytes in this case. So new is like some heap of memory that we can create and save this 3 bytes that we want. Okay, so array 0 is assigned a value of 10. So you can see how it's written. First, you name the array, you call it array, then in this open and close square brackets, you write 0, meaning that you want to assign a value to this specific array. So what if I want to assign a value to array with the index 1? So array 1. What if I want to assign a value? What do I have to do? I'll follow the same procedure. I'll write array, and in open and close square brackets, I will write 1. Why? Because 1 is the index. So basically, I can take my 1 minute. I can take my 1 here. Nope. I can take my 1 here and put it right in here. And there you have it. You can have your 1 in there and then assign a value of, let's say, 20 or 30 to it. So this is your array, and you can assign a value to each one of the elements. Now, let's move on to the next slide and see something else. Here we have 1-dimensional array. What does 1-dimensional array mean? 1-dimensional array with 1 index, an array with 1 index. But we mean 1 index here, we mean, for example, like this, 1 dimension. Okay? just one linear dimension. So let's look at how the parts of array are named. Byte, type of the array elements. Well, I told you that this is the type of elements that we'll have. Name of the array, in this case we named it array. Square brackets indicate that the variable named array is a byte typed array. Now if we don't put this square brackets, what the computer is going to look at this as is it will consider this to be a variable because we don't have these square brackets. Fine. The next thing is creation of an array expression. Here is our expression. Number of elements that we have in our array, 3. So this is called an array expression. This is called the number of elements, and this is called the name of the array. This is the type of the array elements, and the square brackets show us that this is an array. So basically when you say one-dimensional array, it means we are storing values in the horizontal or one-way direction only. Like, let me show you what I mean. So basically here I want you to look at this as an array is something that can save a value like, no, not this direction, this direction. Okay, so we're saving values in one direction only, so we can only have, let's say, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on and so forth. But in two-dimensional arrays we can save values also this way. Okay, so we can save like this and like this, two ways, one direction and the second direction. So one-way array is saving our memory or saving our elements in the horizontal direction. All right, now that being said, we know what one-dimensional array is. We know the type of array, we know the name of the array, and we know, of course, this 3 here. This new, I told you, we'll look at it later, is used just to store new values or to initialize these elements that we have here. Let's move on to the next slide and see. One-dimensional array. Here you can see almost the same thing we had, but in this case, array 0 has a value of 10, array 1 has a value of 20, array 2 has a value of 30. So here we have our array with 3 elements, and this is how to write it. This is how to write it. And then here we are initializing our arrays. We are initializing our array and its elements. We have array 0. It means we are calling this element and we're assigning a value of 10 to it. Array 1, which is this element, and we're assigning a value of 20 to it. You can see 20. And array 2, we assigned a value of 30 to it. So you can see this 30 up here. Basically, you can do something like this. Sorry. You can do something like this, and like this. Then you'll understand that after writing this, we've made the computer understand that we want 3 bytes, and we want them to have the same name, array. And in this name, we want this name to have indexes. So array 0 is this, array 1 this, array 2 this. After this, you can also use the same procedure to print out your values to the screen or to your console. And how is this done? You have console write line, and in open and close parentheses you have array 0. So which array is this? Of course this. What do you want to be printed here? 10. So what do you have here? Oops. You have this 10 goes in here, this 20 goes, no, this 20 goes in here, and this 30 goes in here. Okay, so 30 here, 20 here, 10 here, and then later you print them out to the screen one by one. And here we go. this one is here, this one is here, and 30 is right here. So you can see how you can declare your array, assign values to it, and print it out using this system. Okay? Now, this is using this system of creating the array, but I'll show you different systems and how to do them as we go on. But let's move on to the next slide and see. Here we have the same thing, but in this case, you would see that the difference here is we have short. What do we mean by short? Short has two, as you can see, we have 2 bytes, 2 bytes, and 2 bytes. So just by writing short here, the computer now will somehow allocate 2 bytes to each element. Of course, we still have 3 elements, but in this case, they have 2 bytes, 2 bytes, 2 bytes. Remember, the computer can save information in 1 byte, 2, 4, and 8. So, but in this case, we have 1 for byte, 2 for short, 4 for integer. Okay? So, now we have short array, named array. So here we've created an array, a short typed array, named array, and it has 3 elements in it too. 1, 2, 3, with an index of array 0, array 1, and array 2. Of course, you can have as many as you want, but 3 is just for simplicity. Now, here again, we have a value. We have assigned a value to these 3 arrays. We call the name of the array. Where did we get this from? Well, we got it from here. So, 1 minute. We got it from here, array, and this 0, we got it from here. So, array, 0, array, again, 1, and so on and so forth. And again, what you can see here is we've printed out the values, that is these values, to the screen using the same procedure, array 1. Here you don't have to write short, you don't have to write byte, you don't have to write int. What you just write is the name, which is array in this case, and the index number, and it will print out what you have there. So arrays can be of short type or byte type or int type, and we'll see more of them. And again, this is a one-dimensional array. Why? Because we are only saving numbers in one direction. If we had another line here and another row here, we'll have 2 dimensions, 3 dimensions, and so on and so forth. But I will show you that in a minute. So now that we have looked at a little about one-dimensional arrays, let's go to our Visual Studio and see if we have some examples, and I'll explain, and you'll see these in practice. Let's go there. So here we are. You can see here in this example, this is our first example. You can see that we have our main entry point right here in line 9, and then here in line 14 we've created an int-typed array. This is the type. Remember, in our lesson I showed you that we have a type, and that this open and close square brackets means it's an array. This is the name of the array, and it has 5 elements which are all of int type. So here we've created an int-typed array named array, which has 5 int-typed elements. If they're int-typed, both of them, it means we're correct right now. Okay? So let me just take you back to our presentation and show you how this is. Once again, byte, open and close brackets, name of your array, new byte if you have byte here, and number of elements that you have. So, fine. Let's look at what we have next. Now, in line 18, we now assigned values to these 5 elements. We've called their name array. Remember, this has an index number I showed you. So array 0 is equal to 10. Array 1, we assigned a value of 20. Array 2 assigned a value of 30. and to 50. So basically all these 5 elements here, they have a value of 10, 20, 30, 40, 50. I just decided to name them like 10, 20, 30, 40, 50. I decided to put their values that way, but you can change it. We'll change it and we'll print it out and you'll see. Then from lines 16 to lines 30, we displayed or we printed out all these values to the screen. This is where we display it or print them out. Now, let's run the program and see if we'll have 10, 20, 30, 40. Remember where to run your program, or you can press F5. So here we go. 10, 20, 30, 40, 50. And here. Now we've printed out our values. And let's say we change this last value to, let's say 70. It will change to 70 when you print what you have. As you can see, we have 70 here. So you can change it to whatever you want. You can assign any value you want to it and it will go, as long as it doesn't exceed the maximum that its type can take. In this case, the maximum that int can take. So let's take that back to 50 and we're ready. So here you can see we have a one-dimensional array and we have assigned a value to it. What if I change this to, let's say, 7? Okay, let's start the program and see what will happen. Start. We still have 1, 2, 3, 4, 5. This 7 have not been initialized. Okay. Why? Because we didn't initialize them. Let's try and see. Array and no. Let's say array 5. Assign a value of 60 to it. And let's see if it will work. And then we have to also, of course, we have to print it out. So CW tab. If you want to just, write console, write line very fast without having to write it, you can press CW and then press your tab and tab again, double. Okay, so here array and here we'll have 6 and that's it. So now we should have 6 elements and a maximum of 60. Wait 1 minute. Oh my god, I made a little mistake. Well, you see here we have array 5 and here we have array 6. But if I run this program, what's going to happen? It's not going to print it, okay? It's going to have 0 right there. You can see it here. That's my mistake. Let me just correct it. We have to assign the right index number. The index number is very important, as you can see. So let's run this. And now we have the correct thing. 10, 20, 30, 40, 50, and 60. Of course, you can also have number 7, number 8, and so on and so forth. But I don't need to do that. You can play with it and see what's going to happen. Let's move to our second example very fast and take a look at this example. Now, here we have our entry point, and let's see what we have here. We have a different construction here. Why? Because we have our loop here, the for loop here. Yes, we have loop for, then we have 3 elements. What are these elements called? Remember, we have, so this first one is called our loop counter, okay? The second one is our conditional expression. Where is it? It's here. The second one is our conditional expression, and the third one is like a change, counter change. So if we have here 0, wherever we go in here, we come back here, we change the value of 0. In this case, we have an increment. Okay, fine. So let's step this program and see what will happen. F11 if you have forgotten to step your program. So here we go in. We have an int-typed array named array and 5 elements inside. So we move into our loop type construction, or our for loop construction. Here we have for int I, we assign a value of 0. It's 0. Then after this, look at what happens. We check the array length. Now, what is an array length? The array length is the number of elements that you have. In this case, we have 5 elements. So our length is 5. If we had 7 elements, our length will be 7. Then after this, we go into the block F11 and we check it. I now is equal to 0, I times 2. So 0 times 2. 0 times 2 is still 0. There is nothing you can do with 0. So 0 times 2, 0. If it's like that, then we move to our change of counter and we increase 1. So now 0 plus 1. Once we go out, we'll see 0 plus 1 is 1. And we check it again. Is 1 less than 5? Yes, it's true. So what do? We move into the body and check. 1 times 2. Now we have 2. So we go to our increment again and add 1 to our existing 1. What is it going to be? It's going to be 2, of course. So we have 2 here. Let's see if it will print it out. Yes, it is here. So we have 2 now. We go back and check. Is 2 less than 5? Yes, it is. Let's go again and try. So now 2 times 2, 4. So we should see 0, 2, and 4. Then we go again. We have 2 plus 1. It's 3. And here we check. Is I, which is 3, less than our array length, which is 5? Yes, it's true. Let's go in again and check it. Now we have 3. 3 times 2, 6. So we should see 6 printed out later. Now we go again. Now I is 3 plus 1. I is 4. 4 less than array length. It's true. We go into the body again. And we have 4. 4 times 2, 8. Keep these numbers. We have 0, 2, 4, 6, and now we have 8. So we go up. 4, okay. Now we add 1, it's 5. 5 is 5 less than our array length? No, it's false. So what do? Do we go into the block? No, we jump. We jump to the next loop for construction. And why do we have 2 loop for constructions here? The first one is to calculate our values of elements. The second loop for is to print out the values respectively. Do you remember the values? 0, 2, 4, 6, and 8. So let's see how this printing works. Let's continue. F11. It goes first, checks. Okay, we go into the body. Write what? The first value we had was 0. So print 0. 0 has been printed. Let me just keep it here. And we continue stepping. So now 0 plus 1. It's 1. We check. 1 less than length. Yes, it is. Go into the body. What do we do in the body? We print. What are we going to print now? We're going to print 1. So let's go up and see. Sorry, 2. Yes? Why are we printing 2? Because we had 1 times 2. So it's 2. We add 1 more. Print out. What are we going to print out now? 2 times 2. Because the value of 2 here, the value of I is 2. But then again, I times 2 is 4. So now we are going to print 4. 4 has been printed. Let's do that again very fast. What are we printing now? 6. Do that again very fast. What are we printing? 8. And that's all. Okay? 8 is our maximum number. So why are we using the loop for construction? Well, the loop for construction is used to make the job very easy. It's to make it easier for programmers to work and just to allow the computer to do more of the work rather than programmers. let's just run this program. If you have this code here and you run it, look at how fast it will just do everything. Okay, but in this case, let's bring back our first example. In this case, you have to initialize them all by yourself. You have to type in all these codes so as to get just 5 numbers printed out, or 5 calculations. So now let's take a look at this. What if I gave you, let's say, a number 5,000 here, and I told you to get me all the values of 5,000 here? What are you going to do? Well, 10, 20, 30, 40, 50, 60, 70, 80, 90. Do you think you can sit down and write 5,000 different codes here? 5,000 assignments? No, you can't. Maybe you can, but it will take like forever. And also you have to sit down and print all these 5,000 numbers here. So it's a very difficult job for you to do. Just agree. Okay? But if you had this, when you change it to 5,000, what happens is you let the computer do the job for you. You are not going to do it, the computer will do it. So let's run this one and see. Here you go. You instantly have everything. Let me just put it right in the middle of the screen for you. You instantly have all your numbers here, all your calculations. So you see how easy it is when you know what you're doing. So you can just have this little code and you'll have 5,000, 10,000, 7,000, 2,000 without having to sit down and type all these things. So this is why for loop is used in arrays. This is why we use the for loop, and you'll have 2 for loop constructions. The first construction is to do the calculation. The second construction is to print it out. So you see, this little code can do a lot for you. But if you had to print out 5,000 different elements and you have to type all of them, assign a value to all of them, and then print out all of them, type the printed code, it's a very long way. So that is why this code for loop construction is very important in arrays. Now, let's check the next example and see what we have. In this example, we still have the same thing here, okay? But it's 4, you can see 4 here. But this is a little bit more difficult, okay? This is just another way of initializing your arrays. I'll show you that in a moment. Now, what is written here? In line 4, we've created an int-typed array named array, and in this array, we have 5 elements. Int-typed elements, okay? But the difference here is, here we have 1, 2, 3, 4, 5. What is in this block? This is called the initializator block. This is the block that initializes all of these 5 arrays. So in this block, we have assigned a value to each one of them. 1, 2, 3, 4, 5. You can see that, okay? And in the for loop construction, we have all printed them out. So the initialization is not done by the for loop construction. The for loop construction is just for printing it out. But the initialization is done right in here, right in the array. So let's run this program and see. Here we have 5. Now, this is not a very good idea, because if you had 5,000 codes, does that mean that you have to just sit down and write 6, 7, and so on and so forth? Yes, it means that you have to sit down and do that. So that's why I don't recommend this. Although for small codes or little codes, of course you can do this and it will work. Writing the initialized or initializing the elements right in the array construction. This is also possible. Okay, so now we'll go back to our presentation and I'll show you the different types, and then we can come back here and you'll understand more of what I'm talking about. let's go back to our presentation. So we're somewhere here. One-dimensional arrays, short, remember, 2 bytes for short, 2 bytes for short, 2 bytes for short. So 3 elements, but they have 2 bytes each. So array 0, array 1, array 2. Okay, and this is how to print it. This is how to initialize it. You have seen this work and we have tried it. Now let's move on to the next slide and I'll show you ways of one-dimensional arrays construction or creation. So you can create it this way. You have one way of creating them right here. You have another way and 2 more ways. Now let's look at these 4 ways of construction one by one and see their difference. You can see they are all of a byte type. They can all be of int type or short type. They all have this open and close square brackets, and they all have the same name, array. The difference is in the second part where you have your elements. Okay, so here we have new byte 3. This means that we will have to initialize each one of them individually. Okay, let's take a look at this example first, then we come back and look at all the rest. Let's go back to our Visual Studio. You do remember the first example we checked. This right here, what we have here is our first example. So in the first example, we have the same thing. We have 5 here and we'll initialize it. And to do this, you have to write all these individually, all these elements. Array 1, array 0, sorry, is the first element, second element, third, fourth, fifth element. And you also have to initialize them. So this is exactly what we have right here. These arrays, okay? Now we have seen that, and this type of construction is different from this. There is a difference between them. Why? Because after this 3 here that we have in this open and closed double brackets, square brackets, we have a set of numbers in our curly brackets, and these numbers are the equivalent of the values that we will assign to these 3 elements. Remember, this is our initiator block, or this is how we initialize these elements, meaning we have element 1, 2, 3. Okay, so element 1, the value is 1, 2, 2, 3, 3. But remember that the computer starts from 0, 1, 2, 3, 4. So of course array 0 is element 1, array 1 is element 2, array 2 is element 3. So this first value is going into where? Array 0. Okay, so let's take a look at this very fast too. You have seen it, but let me just repeat it. Okay, this is in our second example, if I'm not mistaken. Is it? Nope. Third example. Yes, it's right here. So you can see that these 5 elements have been somehow initialized by this. So of course now we'll have 1, 2, 3, 4, 5. But with increments, let's run this program and see. You can see 1, 2, 3, 4, 5. These numbers are here. So we initialized these 5 elements using these numbers right in front of our array, just in the code. Okay, so let's go back to our presentation and see the third one. In this third method of creating arrays, you'll see that this number here, 3, we had 3 here and 3 here, but here we don't have a 3. Why? Because the computer, if we have this initializator block, the computer already understands that we have 3 elements. Why? Because we initialized only 3 elements. So here we'll have 3 automatically, but we don't even need to write this 3. The computer already understands it just by our initialization block. Then, moving on to the next one, I'll show you this also in a minute. Moving on to the next one, you'll see that in this fourth example or fourth way of creating arrays, one-dimensional arrays, we don't even have new byte, neither do we have our open and closed square brackets. Why? Because if we have initialized 3 different elements, it means we have 3 elements here. That's number 1. Number 2, if we have byte written here, it means of course it has to be byte here, because there's no other way. We can't have byte and int here. So the computer is very, very intelligent, and it can do this on its own, and you don't even have to bother writing new byte 0, new byte 3. Okay, so let's go back to our code and see these in action. We have looked at this. Now let's go to code 4, or example 4. In this example, you'll see that we have our initializer block here. We have our initializers here. 1, 2, 3, 4, 5. And of course, we have this. What you would see is we don't have any number written here. In the third code, let's see, we had a number written here, 5, in our third code. But moving on to our fourth example, we don't have any number written here. But that doesn't mean that this will not work. If we were to write 5 in here, it's not a mistake. It will still run. But if we don't write our 5, it's still possible, because we have 5 initializers here. We have 5 elements, meaning we have 5 initializers. So let's run the program and see if we'll have 1 to 5 printed. And 1, 2, 3, 4, 5. So you can write, or you can create an array, a one-dimensional array. You can create it in this way too. Okay, let's move on to our fifth example. And in this fifth example, you can see this type of construction without new byte and without open and close square brackets. So let's see. Here we are. No square brackets and no new array, no new int array. Okay, so does this mean that this will not work? No, it means that it will work. It is a way of making it. It's a method of creating arrays. We have our initializers here. Let's run this program and see. It still works. So there are 4 ways of creating arrays, and you can of course feel free to play with all these. Let's imagine I decided to add 1 more here. Let's see what will happen. Okay, 2 more. 6 and 7. Now, will the computer guess that I had 5 elements and now I have 7? I've changed it to 7. Yes, it will. And here we go. 1, 2, 3, 4, 5, 6, 7. What if I had 6? It doesn't matter. The same thing. 1 to 6. So of course, if you feel like, you can do that. If you don't feel like, you can just write it like this. But if you want to write it using your initializer, use it please, by any means. If you want to write new int and in open and close square brackets write 5, feel free to do so. This is your right. If you want to do it, please do it. So let's move to the next example and see. What do we have here? Well, here we have an array here created, an int-typed array named array, which has 5 elements. And in the body here, we have a for loop construction, a for construction. What happens here is we have 5 elements, meaning what? Let's step the program. Here, we move in here. I is equal to 0. Okay. 0 is less than array length. Array length is 5. 0 is less than 5. It's true. What do? We go into the body. Now, I is equal to 0, which means we'll print 0. Okay. So let's print 0. It's here. We've printed 0. Let me just put it here. And what does this do? It increases it by 1. Right now we have 0. We move out. It's 1. Okay. Well, by the way, if you want this to stick here, you can always pin it down here. It will stick. Okay. But we don't want that now. So we check. 1 is less than 5. Yes, it's true. Move on. 1. So we type 1 now and another 0 is printed. We go up, come down, 0, 0, 0, 0. So basically we should have 5 zeros here. 5 zeros here. So you would ask yourself, why is this not increasing it by 1 by 1 by 1? Why don't we have 1, 2, 0, 1, 2, 3, 4, 5? Well, I'll tell you now. It is because we haven't initialized anything. Well, of course we have an array, it's correct. We have our open and close square brackets, correct. Int, it's correct. We have our number of elements, 5, it's correct. But where do you see an initialization here? We haven't initialized it here and we haven't initialized it here. There is no initialization, which means this will not work. And if you run it 100 times, you'll still get zeros. Okay, you'll just have zeros here. Well, let's run it again and I'll show you something. Well, look at this. What do we have here? 0 and int here 0, 2. Let's go down here and see array. Okay, we have 5 ints. Okay, correct. What do we have here? Nothing. Here, number of our arrays. So basically we have zeros all over and all over again. Although this is changing, this I here is number of our element, and that's all. So basically we have nothing here and we haven't initialized it. What if we change this int to something else? Let's say bool. Okay, and here too, of course, bool. Well, maybe it will change something. No, it won't change anything. There's nothing that will change here. Why? Because bool is just true and false. So what's 0 here? All we'll be seeing are false, 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 false. So here we go. False, 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 false. That's it. What if we have something like char? Let's see, char. Let's see. Characters. Maybe we'll get something. Nothing. How about string? String. Still nothing. You don't get anything. So no matter what you do, if you don't initialize it, right, in this case you wouldn't get anything, except if you go and initialize it somewhere here, but I'll show you this in a little while. Okay, so let's go back to our presentation and finish our presentation. Then we come and start two-dimensional arrays. Okay, let's go back. Here we are. So we're going to talk about multidimensional arrays now. Multidimensional arrays are arrays that have more than one index. What do we mean by more than one index? Let's go back to our slide 7 and I'll show you what we mean. Remember when we were talking about indexing here, and we said that the computer starts reading from 0, 1, 2, and first element, second element, third element. So 0, 1, 2, if we want to assign a value of 10 to our first element, which has an index of 0, what we do is we write array, and in this pair of square brackets we put 0, which is the index here. So notice that we have 0 here and it's only one digit. We have 1 here, 1 digit, 2 here, 1 digit. But if we go back to our multidimensional arrays, what you would see is we have 2 digits here. What does this mean? This means that we have two-dimensional arrays here. 1, 2. Okay, so we have 1 and you have a comma and then 2. This means that we have 2 dimensions. If we had 3 dimensions, we would have 3 digits, 4 dimensions, 4 digits, and so on. Now, that's one way to differentiate between arrays, types of arrays: 1-dimensional, 2-dimensional, 3-dimensionals, and so on and so forth. Now, let's take a look at types of multidimensional arrays that we have. We have rectangular types and we have jagged types. Now, the difference between rectangular types and jagged types is that in a rectangular type, you have all your rows and columns that have the same size. If you can see, we have 1, 2, 3 bytes here, 1, 2, 3 bytes here, and 1, 2, 3 bytes here. This means that this is a rectangular array. It looks like a rectangle. Okay. Now, in jagged arrays, the rows can have different numbers of elements. In this example, in the first row we have 3 elements. In the second row we have 2 elements. In the third row we have 4 elements. But to the computer, this is 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2, because the computer starts reading from 0. Okay. Now, I'll show you why these are used and how to use them and so on and so forth. So, rectangular arrays are arrays that contain multiple measurements where all the lines are of the same length. You can say all the rows. Okay, it's still fine. Then jagged arrays are arrays which contain some amount of internal arrays, each of which can have its own unique upper limit. By upper limit, I mean like number of elements. Okay, it has different size. They have different lengths. This has a length of 3 bytes, 2 bytes, and 4 bytes respectively. So, but how do we create multidimensional arrays? If in the creation of singular arrays, we know that, at least let's go back to creation of singular arrays and see where did we create a singular array. Right here, I think. So we had one number here. Okay, what if we have multi-dimensional arrays? Let's say 2 numbers. What do we do? Well, what we do is basically in our signature here, or in our construction, array construction, we still have the same construction, meaning we write the type of our elements, then in this pair of square brackets we have a comma. This shows that we have one array here and one dimension here, 2 dimensions. First dimension, second dimension. If we had 3 dimensions, it would look something like this: 4 dimensions, 5 dimensions, 6 dimensions, 7 dimensions, 8 dimensions, and so on and so forth. But can you really imagine like 8 dimensions? Well, maybe no. So let's just leave it here. We have 2 dimensions and it's fine. And then again, we write the name of our array. In this case, the name of our array is array. And here you can see we have byte type, which is also byte type here. And in this open and close square brackets, you have 3 by 3, which means we have 3 rows and 3 columns, 2 dimensions. Okay, 1, 2, 3. So 1, 2, 3, we have it here, and 1, 2, 3, we have it here. So this is a 2-dimensional array where we have specified here, and then it has 3 rows and 3 columns. So let's imagine that we want to somehow assign a value. Let's say we want to assign a value to one of these arrays. Okay, so what do we do if we want to assign a value to one of these? What do we do when we want to assign a value to one of these arrays? What we do is pretty simple. The easiest way you can do it is just to somehow, let's say, write byte, for example. Then in your open and close square brackets, you have your comma, which means you have 1 dimension here and 1 dimension here. And then you write the name of your array. In this case, array. Next, new, and you have 3 by 3, exactly what we have here. So here we have 1 dimension, here we have another dimension. Okay, now if you want to, let's say, assign a value to this very array, what do? Okay, let's look at what we do. Okay, you write array, Sorry, it's gone. Why? You write array and you write, let's say, array 1 1, which is the number, the index of our array, and then you assign a value, let's say 5. Now this array has a value of 5. If you want to assign a value to this element here in this array, you want to assign a value to this element. Where is this element located? It's located in 1, 2, in the third row and third column. Okay, so third row, we have it here, and third column, it's the last we have here. So you write array you open and close your square brackets, you write what? 2 2 2 is equal to 8. Now why 2 2 and not 3 3? Because 2 2 is the index. 2.0, 2.1, 2.2. Here we have 0.0, 1.0, 2.0. So the computer always starts from 0. You can see 1.0 first, then 1.1, then 1.2. Let me just clear this off. So this is how you can assign a value to each of these individual elements in an array. But then again, you would say, well, arrays are not like, horizontal and vertical lines. In a memory, they are all in a linear construction. Yes, of course, you're right. This is just a representation. I just want you to understand how the system works first, and then I'll show you. But in the linear system, it's the same thing. Arrays are, let's move on to the next slide. In the computer, they are represented like this, not like this, with rows and columns. They are represented like this in a linear construction, one row, okay? But then again, it's almost the same thing. Why? Let me show you why I think it's like that. Just because if you look at this, we have 0.0, 0.1. This is our first row. 1.0, 1.1, first column. As you can see, here we have our first row and first column. So if you were to take this and put it right under here, you will have a two-dimensional array with 2 rows and 2 columns, and you have 2 digits. But the computer just doesn't do it like that. It has just like a linear construction. But I want you to understand that it's basically the same thing here. And the assignment is also like this. So you have array 0.0, assign a value of 10. Where is this 0.0? It's right here. This is what we assigned a value of 10 to. You can see this 10 is put right in here. So this element has been assigned a value of 10. This element has been assigned a value of 20. And this element has been assigned a value of 30. And this element has been assigned a value of 40. So you can see how this works. It's very easy for the computer to just calculate this, but imagine we have 3 dimensions, 4 dimensions. Well, I wouldn't be able to explain this in a linear line with ease. You might not understand it completely. So that's why I thought of creating it in a 2-dimensional way so that you can see how it works. Imagine just like you have a library, okay? And in this library, you have 2 bookshelves. Now, first bookshelf, second bookshelf. And let's say in this bookshelves, you have, let's say, 2 divisions or parts. And in these divisions, you have also something. Okay, let's just make it easy like this. So if a book was somewhere, if a book is somewhere, let's say here, this is what? This is 0 to the computer, and this is 1. Okay, so this is 0 bookshelf and 1 bookshelf. So bookshelf number 0, bookshelf number 1. If I asked you, where is the book? And you can tell me it's in bookshelf 1. Okay, but I'll have to look for it here, and you know, if I had a lot here, let's say I had a lot here, I would have to look for it here first, here, 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 yes? But no, we don't want to do that, so we divided them into, let's say, elements. This is, let's say, 0, 1, and this is also 0 and 1. So this is 0, 1. So if I asked you where this book is, what you would say is it's in the first bookshelf, and 0, let's say, division. If the book were here, what you would say is it's in the first bookshelf, bookshelf number 1, not here, here, and it's in the first division. So not in the 0 division, but in the first. So this bookshelf, this book is here. So let's do that again. This book is here, and this book is here. You can see it's like an address. Okay, so that's how basically a two-dimensional array works. Its elements, which are here, all have indexes, and with the help of these indexes we can assign values to all these elements. This is like a two-dimensional array. And then again we have 3 dimensions. We'll look at that in a few. Let's clean this up. So let's go to Visual Studio and look at this as in practice so that you can see how it works and everything. We are now in the Visual Studio and we're going to look at two-dimensional arrays. This is our entry point, as you remember, and this is our construction. You already know what this means. This means that we have 1 dimension here and 1 dimension here. So here we have a two-dimensional array. Okay, it's an int type. How do you read this? Very interesting. Do you remember how to read these codes? Very easy, yes? Look at it. We have created an array. Here we've created a two-dimensional array of int type, and its name is array. So we named it array, and it contains a two-dimensional 3x3 element operator here. This simply means that we have 2 dimensions here because we have a comma here, and then we have 3 elements here and 3 elements here, 3 rows, 3 columns. So let's look at it. We have 1 2 3 1 2 3 1 2 3. So 9, just like 3 times 3, 9. So you have 9 elements. You can see all your 9 elements here. So let's step this program and see. But before we step it, I'll just like to tell you that from lines 13 to lines 23, what we have done is we've assigned values to these elements that are present in our array. You can see for the first one, for the first element, which has an index of 0, 0, we assigned a value of 1, 2, 3, 4, and so on. So when we print this out, what we should see is 1 to 9. But we'll step it before printing it out. So in this block here that we have, we've assigned values to each element in our array. And from lines 25 to lines 35, we have printed out. This is where we ask the computer to print out each element, to print out the value of each element to the console. Now look at this. In printing it out, you write console write line, and in a pair of parentheses, you write array, which is the name of this array. Okay, we have array, and then in a pair of square brackets, you write the index of that array which you want to be printed. In this case, we want 0, 0 to be printed. So we write 0, 0. What would you see here? You would see 1 to the screen. Okay, fine. Now let's step the program. F11. So here you can see we have null, 0. Right now it doesn't have any value, and here we have integer types, full number types, whole numbers. Then when we move down, what you would see is, notice this, when you open this, you would see that initially all our elements have a value of 0 initially. That's before we somehow assign a value to them. All of them have a value of 0. Why? Because the default value of integer is 0. That's why all of them right now have 0, but here we'll initialize them. We'll assign some value to them. So let's step down a little. Here we are initializing. We have assigned a value to this one. So you can see the first one is already 1. It has changed to 1 from 0. But the second array is still 0. So when we just step out, it will change to, yes, you guessed, 2. Where did we get the 2? Here. This one is equal to 3. But right now it's 0 first, as you can see, 0. But when we step out, we get 3. So let me just do that very fast. And there we go. We have assigned a value to all our elements in our array. Now, right now we haven't printed anything yet. As you can see, 1 minute, as you can see, nothing has been printed yet. So I'll just put this somewhere here, and let's start printing them out. So we have F11, and hopefully we've printed 1, as you can see. The value of 0.0, 0, is 1. So we've printed 1. And let's initialize this. 2, initialize this. 3, initialize this. 4. But you can see we have 1, 2, 3, and then we move to the next row. Yes? So we have 1, 2, 3 in one row, and we move to the second row and start printing 4, 5, 6, and we move to the next row and have 7, 8, 9. Why is it so? Because we have 3 by 3. So it reads 1, 2, 3, 1, 2, 3, 1, 2, 3. And at the end of the day, we'll have 1, 2, 3 and 1, 2, 3. So let's just print that out very fast and see. Let's go to the last one. And here we go. So we have 1, 2, 3, 1, 2, 3. 3 rows, 3 columns. Okay? And that's it. And that's how to assign a value to individual elements in your array and print them out individually. That's one way of doing it. But of course, there are other ways of doing it. All right? Let me show you something else. Here we have another way of initializing them. You do remember when we printed out, asterisks, and we printed a square made of asterisks and, a triangle made of asterisks? Well, this is the same method we are using here. Arrays are usually used, or most of the time, they are used with the loop for construction. So they are used with loop constructions. Why? Because it's easier. And I'll show you why right now. So here we have a loop construction, and in this loop construction we have a nested loop for construction, and we have in line 22 another loop construction for loop construction, and in the body of this loop for construction we have a nested loop for construction. I'll show you why we did that right now. So as you can see, we have the same construction here. We've created an integer typed double dimension or 2-dimension array which has 3 by 3 elements, which has basically 9 elements in it, all of integer type. So, but you would see that here is where we assign values to our elements, and here we print out all the elements. So we have this 4 for assigning elements and this 4 for printing out elements. Now, before we step this program, let me show you something. I'm just going to put this side by side so that you can see. This was the method we used to assign values to individual elements in our array. And now we're going to take a look at using for to assign values, or fill in the array as it's called, fill in the array. So here you can see fill in the array has taken a lot of time and space. Here it will take less time. Imagine that you have not 9 elements, but let's say you have 200 elements. Do you think it's easy to just sit down and assign a value to each and every of them and then print out each one of them individually? Of course, it will take time. But right here, you can do it very fast. With this code, you can print out in 5 minutes, you can print out everything you want to print. So that's the difference between them. You have a difficult or not very comfortable way of filling in your array and printing out your array, and this is a little bit more easy. It's more comfortable both in filling in the array and printing out your results. So let's close this. I think you have seen this, and step this program. F11. Right now our array is 0. When you step in here, you will see all of our elements have a value of 0. And then we move into this for loop construction. Here we have 0, I is equal to 0, I is 0, which is less than 3. It's true. So what do? We move into the body. Moving into the body, j is equal to 0, and j, which is 0, is less than 3. It's true. So let's move up. I 0, j 0, 0 times 0 plus 1 is equal to 1. So now when we move up, what you would see is in our array here, we have printed 1 right here. We have assigned 1, but we haven't printed anything yet, okay? Because this is not where we print. We print right in this construction. So, but we have assigned 1. This is our 1. We have assigned 1 to array to the element with 0.0 index. So that's how it works. We move, check in it. J is less than 3. What's the value of j? J is 1. Of course, it's less than 3. So we move here. We change the value of our counter. It's 1 now. It's going to change to 2. So it's 2 now. J is less than 3. It's still true. And you repeat this process until you have 1, 1, 1. Why do we have 1, 1, 1? You'll see it right now. It's going to change. So it changes as you go on. I have 1, 1, 1, 2, 3, and the rest. Let's see what we have now. So 1, 1, 1, 1, 2, 3, 1, 3, 0. Once we finish that, the last one will change. 1, 3, 5. Okay, so we have a value here. Okay, but then we move in here. What's the value? Why do we have 1, 1, 1? Let's see it here. If you were to print this out, you will see 1, 1, 1, 1, 2, 3, 1, 3, 5. Yes, we don't have the same thing in the previous one, but this is because our code here wants us to print. What we wanted to do was to print 1, 1, 1, 1, 2, 3, 1, 3, 5. That's what we wanted to do. That's how we created this code. We didn't create this code to print 1, 2, 3, 4, 5, 6, 7, 8, 9. We created it to print exactly what we're doing now. That's why when you step it, let's step it again. Here you have I is 0, 0. Remember, all our arrays are 0, and we move. I 0 less than 3, yes. We move in here. You open this. Sorry. You open this and you see it's 0. J is 0. J is less than 3. Yes, it's true. If J is less than 3, what we want the computer to do is to move in here. Now, I, which is 0, and J is 0. So here in your row, 0, comma, colon, 0. Row 0, colon 0, you remember what it was, the first one. Then we assign a value of, okay, let me just show you that since we want that. Row 0, colon 0, we assign a value of I multiplied by J, which is 0 multiplied by 0 plus 1. So 0 multiplied by 0 plus 1, we have 1. So we've assigned 1 to that. And we move up. That's why we have 1 right here. And now, when we step this, we've increased by 1. We come here. J is now 1. 1 is less than 3. We move. J is 1. 1 less than 3. We move in here. I is equal to 0. J is equal to 1. So we are moving into the element which has 0, comma, 1 index. And we assign what to it? 0 multiplied by 1 minute. 0 multiplied by 1. You have 0. 0 multiplied by 1 is still 0 plus 1. What do you get? 1. So in our element which has an index of 0.1, we want 1 to be there. So we move up. Now 1 should be there. Let's see. 1 is there. Then let's move on. J is 1 still. 1. J has changed to 2. Why? Because we increased 1 here. We have an increment change here. So J now is 2. 2 is less than 3, which is true. We move into the array. But I is still 0. You see, this is where we get our I from. I is still 0. We are still in 0 row. So 0 times 2, 0. I is 0. 0 times 2, 0 plus 1. 0 plus 1, we still have 1. That's why we assigned 1 to it again. Let's see. You can see 0.2, 0 times 2 plus 1, which we added, is still 1. But now look at this. When we go out of here, now J is equal to 3. And 3 is not less than 3. So here we'll have false. Well, if we have false, what do? You step out and you move up here where you have your outer for construction. Outer for construction, I right now is equal to 0. But when we step out, I will change to 1. So 1 is less than 3. It's true. What do? Move into our nested loop for construction. J is 3. Okay. J has changed to 0. Why? Because we assigned a new value to J here. When we come in for our second iteration, we assigned a new value to J. So here we have J is less than 3. It's true. If it's true, we move into the body of our nested loop for construction. But I is 1 now. Remember, I has changed to 1, not 0. But then again, 1 multiplied by 0, it's 0. 1 multiplied by 0, 0. But plus 1. If you add 1 to it, it will be 1. So the next number we're going to have is still 1. And you can see 1 multiplied by 0, it's, well, 0. And then we add 1 right here and it becomes 1. So that's why we have 1. And when we move up, let's see, j1 less than 3, it's true. Why? Because we just increased j here. And we move on. Now j is 1, I is 1. So 1 multiplied by 1, it's 1. Okay? 1 multiplied by 1, 1. Then plus 1. We have 2. So the next number is 2. Let's see. 2, as you can see. Then we come here, we add 1 to j. j is equal to 1 now. We add 1, j becomes 2. So 2 is less than 3. It's true. Let's go into the body. 1 multiplied by 2. Right now we have 2. 1 multiplied by 2, 2. Plus 1. We have 3. So the next number we're going to print is 3. Let's check it. Let's check it together. 3. Very good. So what do? We go in here and see j is equal to 2. Well, j3 is less than 3. No, it's false. If it's false, we don't go in here, we go up. So we go up. Now we add 1 to I. Remember that our I was 1. But now when we increase 1, I becomes 2. So 2 is less than 3. Yes, it's true. If it's true, we move into our nested for construction. J is 3, but we'll assign a new value to j, which is 0. So when we move out, j is going to be 0, which is less than 3. So we move into the body. I is now 2, but j has been changed to 0. So 2 times 0, you'll get 0. 2 times 0, 0 plus 1. The next number is going to be 1. So let's check that. And after 3, the next number is 1. And that's how you continue. And that's how we get all the numbers. So you see, this is how we program this program to work. The last one. This is how we programmed this to work. It's not like a mistake or something. Then after, of course, this loop for construction has finished its work, it will give it to the printing, let's say printing press, okay, or printing loop for construction, the printing part. And it will repeat the same thing, printing them one by one. 1 has been printed, move again, 1 again, 1 again. But what are we going to have next? It's not going to be here, it's going to be down here. Why? Because we have, remember, 3 by 3. So 1, 1, 1, and we'll have a number here. I'll just finish this up. Let's see, and that's it. 1, 1, 1, 1, 2, 3, 1, 3, 5. So you see, this is a better way of doing the job. Okay, let's move on to the next example. In this example, we'll have like another way of assigning it. Of course, it's not a very easy way because you have to assign a value to each and every one. Each and every element. Let's see, what do we have here? From the main, what we have is int, an int typed array, two-dimensional named array, and you assign a value to each element, as you can see here. So element 0.0 will have a value of 1, element 0.1, 2, and so on. And of course, for simplicity, we use the loop for construction to print it out. I just wanted to show you that we can also assign a value right in the array construction. So here we have it. And when you print this out, of course, you see 1, 2, 3, 4, 5, 6, 7, 8. Let's just print this out very fast. And here you go. 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically this is how this works. And step in this program also, you'll find out that this step is just one step. Okay, one step, and you've assigned everything. But it's difficult if you had, let's say, 200 elements or 1000 elements. Of course, it's difficult. It's better for you to sit down and create a loop for construction that would do what you want. Okay, fine. Let's move on to our presentation, finish the presentation, and come back to our examples and do something. Here we are. Now, of course, we are done with this. We have already seen what this is, two-dimensional arrays, and this is how to assign values to them. Of course, you remember 0, 0 is 0, 0 element. Fine. Now, let's move on and see jagged arrays. Jagged arrays, I told you, are arrays that have different number of elements in each row. So here we have a good example of a linear construction of jagged arrays. This is what it should look like in your memory. In this example, you can see that here in the first section we have 2 bytes. In the second section we have 1, 2, 3, 4. We have 4 bytes. So the first element has 2 bytes, second element 4 bytes, and of course it can go on so and so and so. So here in the first element, notice that in the first element we have 2 bytes. Each of these elements in this array, in each of these element has an index 0, 0, 0, 1. So each of them can be assigned an individual value. Alright, now in the first element, this is element 0, this is element 1. The first element has 4 different values. You can see 1, 2, 3, 4, and each of them of course has its own index number. So of course you can move on and on. Here I think it will not fit into our presentation, so these 3 dots are there to show you that you can imagine this. All I want you to understand is there is a difference between jagged and rectangular arrays. Jagged arrays can have elements which have different values, whilst in rectangular arrays you have the same number of elements in each row and in each column. Alright, fine. Let's move on to the next example and see what we have. Here we have 3-dimensional arrays. An array with 3 dimensions might be difficult for you to somehow imagine, but we'll take a look at this and use our library example just to make sure that you understand everything. Here what we have done basically is we've created a 3-dimensional byte-typed array. Remember I told you 3 dimensions is denoted with this 2 commas, okay, in our pair of square brackets. So what type of array do we have? Byte type. How many dimensions? 3 dimensions, because we have 2 commas. Here we have the first measurement, first measurement is here, second measurement is here, and our third measurement is here. So basically we've created a byte-typed 3-dimensional array named array, which has 3 by 3 by 3 number of elements in it, and the elements are of byte type. So here let's say we have our depth, we have our height, and we have our width. So you can see height, width, and depth. This is like a 3-dimensional representation. Of course, we know that it's not like this in the memory. In the memory, it's a linear construction in the memory. But here I'm just using our library, explanation just for you to see that it can also work like this. So let's try it and see. Let's imagine that this is our first bookcase, second bookcase, and third bookcase. So we have 1, 2, 3 bookcases. And in each bookcase, we have rows and columns. So, of course, you can see 0.00. What does this mean? This means that this is bookcase 0. You remember that computers start reading with 0, 1, and 2. So this first 0 means that this is the 0 bookcase, And the second 0 means that it's in this direction. It's on this shelf. So let's imagine that each bookcase has 3 shelves and 3 sections. Okay, so shelf number 1, shelf number 2, and shelf number 3. And of course, like this, like this, like this, like this, like this, like this. Then again, each bookshelf has 3 sections: section 1, section 2, and section 3. Now you can imagine this here and here. I don't have to do that all the time. So what we are doing here is, here we have 1, 0, 1, 2. So this is 0, which is here, and it's in the 0 shelf, and it's in the 0 column. So 0 bookcase, 0 shelf, 0 column. Now let me take that here, and you'll see. Here we have the first bookcase, 0 number 1, but it's in the 0 shelf. So we have 0 shelf and 0 column, 0 column. So you can see 1, 0, 0 means this one. Okay, let's clean this up. Okay, let's leave it like this. Now, if you have something like this, what we are going to do now is to try and look for a book. Let's say we want to look for this very book, 2.1.1. We write byte, and we have our open and close square brackets array, and this is our construction. So we write array, array, and 2.1.1. This is what we are looking for. What if we had, let's say, 2.2.2? How do we look for this book? Or let's say, how do we look for this book? Or let's say, how do we look for this very section? Now we go to the second bookcase, bookcase 1, bookcase 0, bookcase 1, bookcase 2. So it should be here, bookcase 2, our first 2. Then what is this 2? This 2 means our columns. So 0, 1, 2. Where here? It has to be somewhere here. This second 2 means our rows. So we have 0, 1, 2. So we have found our book. It's here, 2, 2, 2. So this is how, let's say, we can represent this. This is like a representation of our library. Now, of course, we know that it's not like this. It's in the linear form. Let's take a look at it in the linear form and see how it will work. In the linear construction, it's almost the same thing. Here we have our complete array. Again, we have 3 dots here because it will not fit into our, we have 3 dots here because it will not fit into our presentation. So here what we have is, we have our whole array. This is the array, and in this array we have 3 dimensions, 1, 2, 3. Okay, but where can we see these 3 dimensions here? Look at here. We have our first here. This is like our first bookcase, second bookcase, and so on and so forth. Okay, but then in these bookcases we have shelves too. So let's change this. These are shelves, and in these shelves we also have sections. Section 1, section 2, or elements, and so on and so forth. You can imagine the rest here. So what do we mean here? What we mean here is, look at the first two. We have 1 minute. This first two here means 1, 2. So we have two different bookcases if we're still using our library example. Then this second two means that we have 1 and 2 shelves, let's say, for example. And this third 2 means we have 2 sections. 1, 2, 1, 2. So basically, this is how you can imagine these linear constructions as if they were in 3 dimensions. Of course, I know if I hadn't used that library example, it might be a little bit more difficult for you to understand. But all the same, you have the same construction. I guess you understand it now. So let's take a look at how we can assign values to them. Array 0, 0, 0, and we assign a value of 10. Where is this array 0, 0? Let's look for it. It's here. This is where it is. Okay, 1 minute. This is our array 0, 0. But in this array 0, 0, we have 3 different positions. We have, of course, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0. So this one is this one is this, and this one is this. So each of them can be assigned a value individually without disturbing the other one. Now, you can see here we have 0, which means we're in this section. The second 0, we're in the shelf, 0 shelf, and the third 0, we're in the 0 section. So this is how you can imagine this. Now, let's close this. What we are going to do is we'll go back to our Visual Studio and look at some examples. See how we can imagine this and see how it looks like in the code. Let's go back to Visual Studio. Now, Visual Studio, we'll go to 3 dimensions. But before 3 dimensions, let's take a quick look at one element. For one element, of course, you can have an array with one element. It's not a crime. It's okay. You can have an array with one element. And how do you create this array with one element? It's very easy. Look at line 11. In line 11, we created an int-typed array, one-dimensional, because we don't have anything inside. We don't have a comma. So we've created an int-typed one-dimensional array named vector, and it has one element in it. And in line 12, we've assigned a value to our vector, which has an index of 0. We assigned a value of 100 to it. Then in line 13, we just print the value of vector, and that's all. 0. What's the value of vector 0? 100. So we print 100 here, and there is nothing to it. Now, look at matrix now. Why did we name this vector? Because it's just one line. You know what a vector is. It's one directional line, and that's a vector. But a matrix now can have horizontal and vertical axis. So in line 16, we created an int-typed two-dimensional array named matrix, and it has 2 elements in it. It has, let's say, this is our x-axis and this is our y-axis. So here you have the same thing. If it were, let's say, a library, what we would have here is our bookcase and here our shelf, and that's it. It's a very small library, very, very small. Now, in line 17, we assign a value to our elements. What's the value of element 0.0, we assign 200 to 8, and in line 18 we just print it out. So this is how you can create one element arrays. Very easy, and there's nothing to it. Of course, you're not going to use this a lot, so I'm not going to talk a lot about it. Let's move on to our 3 dimensionals. This is how a 3-dimensional array looks in a code. In line 11, we've created an intyped 3-dimensional array which has 3 by 3 by 3 elements in it. So meaning 9 elements times 3. So you can calculate that, about 27. So anyway, and this looks very familiar to you right now. This block, where we're initializing our elements, each and every one of them. Now, let's remember our library. What is this first 0? What does it mean? It means our bookcase 0. What's this second 0? Shelf 0. What's this third 0? It means it's in the 0 section. So this is how we can do it. And what if we move down here? It's another bookcase. It's not bookcase 0. It's bookcase 1. But shelf 0 and, of course, section 0. So we've assigned values to all these elements that exist in our library, or in our array in this case. Now, here you'll notice something has changed. In our 2-dimensional arrays, we had only 2 for constructions. We had 1 and 2 in 2 dimensions. But in 3 dimensions, we have 3 different for constructions. Well, they are nested, of course, but we have 3. In any case, what this first one means is the sections. This is the operator or the for loop that calculates the sections, in which section a particular book or value is. This is what calculates the shelves, meaning in which shelf that particular book is first, and then we go to sections. And this calculates, let's say, the bookcases. Okay, so first we determine the bookcase, then we determine the shelves, and then we determine the particular section or division where that book is located. So let's step this program and see. Let's step it one by one. Of course, you move into your main, and I'll show you something. Right now, all the values of our elements are 0. You can see all of them, 0, 0, 0, 0, 0. This is our bookcase, this is our shelves, and these are our divisions. So here we've assigned a value of 1 to this, and once we go out, you'll find out that here we have 1. Okay, now next one, 2. So in 0 bookcase, 0 shelf, and 0 section, we have book number 1. But in 0 bookcase, 0 shelf, section 1, we have book number 2. And now we'll see, once we step, I'll step it like this. We're done with the first bookcase. Let's take a look at that. And you can see the first bookcase has been filled. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So books number 1 to book number 9. But the next bookcase, which is bookcase 1 with index 1, we have all zeros because we haven't yet assigned values to 8. And once we assign values to 8, you'll see it will be filled. So we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so here we go from 1, 0, 0 to 1, 2, 2. We've assigned a value to them. And you continue. Now we've assigned a value to all of them. and we'll start printing them one by one. We'll start printing what? From the bookcase. Which bookcase? Bookcase 0. So right now I should be equal to 0. Well, you can see that I is equal to 0. So it means we're in the 0 bookcase. And less than 3. Yes, it's correct. Why? Because we have 3 dimensions here. And we go into the body. Now what are we checking? For the shelf. Which shelf? J. So J, 0. Fine. We know that it's in 0 bookcase. We want to know what is in 0 bookcase and 0 shelf. Is 0 less than 3? Yes, it is. So we check the 0 section. In the 0 section, what do we have? K, 0. So we add 1 to it. Let's go out and print that 0. What do we have there? 0. Okay, we add 1 to K, and now K will be equal to 1. So what this means is that in 0 bookcase, 0 shelf, and of course 0 section, we have book number 1. So if we just print that out now, what we'll have is we'll have book number 1. So book number 1 is there. Let's check what we have next. We go to the second. Let's see. We have 2. So what this means is that in 0 bookcase, 0 shelf, and first section, we have book number 2. It's here. Let's add 1 more. Now K is less than 3. Of course, K is 2. And we print 3. Now K is 2. 3 is there. It means what we have in 2, we have book number 3. How did we know that? We know that because here we have 2. K is 2. Let's imagine K is our section. J is our shelf, and I is our bookcase. So in bookcase number 0, shelf number 0, division number 2, we have book number, let's see, book number 3. So let's see, 0, 0, 2, 3. And we have our 3 right here. So that is how it keeps on going until you have filled all of them. One thing I want you to notice is we have 3 dimensions, 3 by 3 by 3. So 3 by 3, we have 1, 2, 3, 1, 2, 3, and that's how it will go on. If I keep on, let me just do everything and I'll show you what I mean right now. It's ready, I think. So we have 3 by 3 by 3. 3 times 3 times 3. We have 3, 3, 3, 3, 3, 3, and so on. Basically, that's how you work with 3D, 3-dimensional arrays. You might not work with this a lot. Not everybody uses this, but I just want you to know how it works. So let's move on to the next example, example 12, and we have almost the same thing. But the difference here is, you see, we're using a block of initializator here. So our initializator block will initialize our elements before we even go to our printing section. So the same example and the same, you're already familiar with all of this. What we're going to do is I will step it now and you'll see how it will assign these values to our elements very fast in just one step. So F11, you see it has assigned all the values, and we go into our printing section. Once you finish one circle, you'll have 1. You go again, another circle, 2, 3. Let's do some more and see how many. Okay, now we have 4, 5, 6, and so on. So this is exactly the same thing here. We have our bookcase, we have our shelves, and of course we have our divisions. So Here we have the same idea, but in this case we are using a block that initializes all our elements in one step. So we have to sit down and write all these values and assign them to our elements. So this is just another way of doing or using three-dimensional arrays using the initializator block. In the next example, I know you're very interested in seeing what 4D is. So imagine that in this case we have the same library idea, but we have an extra measurement, the fourth one, sorry. If in one dimension we had only one element or we had one measurement, in 2 dimensions we had 2 measurements, in 3 dimensions we had 3 measurements, in 4 dimensions we have 4 measurements. But what can it be? Well, if we have length, breadth, width, what else can we have? Length, breadth, depth, sorry. Here we have time. This is like our 4th measurement. Okay? But then again, before we move into that, look at our first bookcase, second bookcase, third bookcase, 4th bookcase. And straight up, look at this. 1, 4, 2, 4, 3, 4, and 4 loop constructions. So we have 4 loop constructions here instead of 3 for our 3-dimensional. For 4-dimensional we have 4. This of course calculates our time. This calculates our bookcase. Well, if we're still using the library, this calculates our shelves and sections. So let's take a look at how this works. Now, I want you to imagine this, that in the future, and libraries tend to be like a 4D scenario, okay? And the librarian sits somewhere, let's say on her seat, okay? And these bookshelves rotate around her or him. They rotate. So if you go and ask a librarian, what I want to get, let's say Shakespeare books, she will just say, wait for like 3 seconds or 5 seconds, and these shelves rotate around her, and she just picks the she just picks the book and gives it to you. So that is how 4D might work. But of course, it's just an imagination. I'm not crazy. It's just an imagination. Okay? And this is, let me just draw something and show you. In 4-dimensional, let's say this is our library worker sitting here, and there are bookshelves and bookcases rotating at, let's say, 2 seconds interval, and they rotate, and somebody is here asking for a book. So these bookshelves rotate. As they rotate, let's say this is 0 bookshelf, 1, 2, and 3. And within these bookshelves, we also have bookcases. We have shelves. We have, of course, sections. And let's say we have 2 shelves here, 2 sections, and it's okay. All right. So this moves around her at a speed of 2 seconds per bookcase. So bookcase goes like this. 2 seconds, we have 1, 2 seconds, 2, 2 seconds, 3, 2 seconds, 4. And this is how you can imagine a 4D library. But this is just an imagination. So let's take this out and see how it works. In line 11, we've created an in-typed 4-dimensional array named array, which has 4 measurements or 4 elements. So these 4 measurements are here, 2 by 2 by 2 by 2. What do we mean by this 2 by 2 by 2 by 2? Let's take a look at it. This is just, let's say, the number of our measurements: 2 bookcases, 2 shelves, 2 divisions and 2 seconds, let's say time or something, 2 something time. Fine. So here we have like our initializer block. In each of these, what we have here is, let's say 0 bookcase, 0 shelf, 0 bookcase, 0 shelf. This is 0 bookcase, 0 shelf, 0 bookcase, first shelf, and so on and so forth. And now, of course, you have this in hex number. Remember, 0x is for hexadecimal number. So you initialize all these and you give them a value of 0, 1, 2, 3, and so on and so forth. Even here we have A, B, C. You're going to take a look at this. And then here we also have 4-dimensional force, 4 loop constructions, which of course will print out our work for us. This is not something that you can really clearly understand right now, but I want you to just understand how you can initialize them, how you can write the code or the array, and how you can initialize, how you can print out what you have. As we go on in our courses, we'll go into this very deeply, but not everybody uses this. Usually everybody uses 1-dimensional and then maybe the 2nd-dimensional arrays. Those are the most 2 important arrays. 3rd dimension, 4th dimension, you don't really need them, but we'll see how that works also. Let's move on to the next example. And here you have the same example, but here we are using an initializer block. This block initializes everything for us. So at one step, if you're to step this program, what you will see is boom, everything has been initialized. So in that case, we had to initialize them one by one. In this case, we're using an initializer block and it initializes everything for us, and we go straight into our printing process and so on and so forth. And there you go, but we don't need that now. So basically, you can initialize them yourself one by one, or you can use an initializer block. It's still fine. That is for 4 dimensions. Let's go into jagged arrays. Jagged array is also the same thing here. The only difference is in jagged arrays, of course, we have different numbers of elements. Here in this jagged array 0, we have 2 elements. In jagged array 1, we have 5 elements. In jagged array 2, we have 3 elements. So in this array, in different sections of the array, we have different types of elements. Sorry, not types, we have different numbers of elements, but all of them, of course, have to be of the same type. Here we have int typed, int typed. For jagged array, you can see that we have 2 pairs of square brackets. This shows the computer that this is a jagged array. So how do we read this? In line 12, we created an int typed jagged array named jagged, and it has 3 elements in it. So that's fine. So 1, 2, 3, and each element has its own number of, let's say, values. 2 values, 3 values, sorry, 5 values and 3 values here. The outer loop iteration through all nested array is performed. So of course, what do we mean by outer loop? This is the outer loop and this is the inner loop or nested loop. So let's step this program and see how it works. First, of course, we move into our array construction and we move into our outer loop. We look at I is equal to 0. Well, this is our construction. We constructed this. I is less than jagged array length. Yes, it's true because we have 2 here. 0 is less than 2. Now 3, sorry, let's go because we have 3, sorry. Here we have 3, so our length is 3. 1, 2, 3. And we moved into the next one, which gives access to each element of the nested array. And we move into each element. Let's see, j now 0. You add 1 to j, it becomes 1, and 1 is printed. Let's see. 1 has been printed. And we move on. J should be 2 now, and 2 will be printed, and so on and so forth. So this is how jagged arrays, if I were to just run this all over, you'll see that we'll have something like this: 1 2 1 2 1 2 3 4 5 1 2 3 4 5 1 2 3 1 2 3. This is how jagged arrays use. They give us the ability, or they allow us to use different numbers of elements in our array. So our array might have 3 iterations or 3 counts, but we also have different elements in it. Let's see how we can use an initializer block for jagged array. If here in example 15 we initialize them one by one, here we have an initializer block 2. Here we have a different thing. Here what I want you to notice is we have 3 here. We have 3 iterations. We specify the number of iterations we want to have. So 1 2 3, it's fine. But if we move to our 16th example, look at this. We don't have anything here. There should be 3 here, but we don't have a 3. The computer already knows that we have 1 2 3. So of course we don't need to put 3, and when we run this program, what we'll have is the same thing. We'll have the same 1 2 3, and that's all. 3 elements, it's fine. So you don't have to put this. Remember, I told you that we have different ways of creating arrays. Sometimes, let me just go back to our presentation and show you that. Sometimes we can write byte without anything in it. Look at this. We have 3 here. Here we don't have anything. This is the same thing with our array. Let's go back to this array. You can see here we don't have anything, but in the 15th example we have int and 3. So basically that's the only difference between these 2 constructions, but they are all the same and they do the same job. Okay, fine. So next we are going to look at methods with arrays, how you can of course create arrays with methods and so on and so forth. So what do we have here? We have created an int-typed method here, int-typed array named modified, and it has a kind of something here. What do we see here? This is like a method that contains an array inside. This is like an int-typed method array. So in our method we put our array as our argument. Okay, so our array here is just like our argument. Here we have 2 elements, our array and our int modifier. Our int modifier is this. I'll show you what it does in just a moment. So basically modify arrays is just when you have passed your array into a method as an argument. So let's step this program and see how it works. We're moving into the main body, and you see here my array. What is my array? My array is just somewhere here. You'll see it now. We've created my array, and it will assign 1 2 3 4 5 elements to it. We go down, my array. This is a new element we just created, new int-typed array named array, which has 5 different elements in it. And in line 22 we assign the value of modify array with my array and 5 inside. So basically we're going to take this value, the value of this operation, and assign it to my array, which is this. Let's step to the next thing. So what are we doing here? Here we are calling this, so we go into this. You can see modify array, my array, modify array. So we move into this body, and of course we keep on calculating. This is our for loop, and you know what for loop does. This is our modifier, array multiplied by I. Here I is 0, so it keeps on. You already know this. If you want, you can play with it, and it returns your array. And here you have it. once you're done doing this, what you'll have is 5, 10, 15, 20, and 25. So we are basically multiplying 5 by 1, 5 by 2, 5 by 3, 5 by 4, and 5 by 5. So where did we get this multiplication from? We got it from right here. First, I is 0, and we change it to 1. Remember our increment sign. I is 1. I multiplied by our modifier. So what is our modifier? Here we are passing our modifier as f5, sorry. So this 5 goes in here. So if this 5 goes in here, it also goes in here. So 1 times 5, 5. Next we put this 2, okay? We put this 2 right in here. So 2 multiplied by 5, 10, 3 multiplied by 5, 15, 20, 25, and that's why we have this 5, 10, 15, 20, and 25. If you want, you can play with this and just see how it works, change some values and see how it will work. But next, let's go ahead and look at params. What is a param? Keyword param allows us to determine the parameter of the method that receives a variable number of arguments. So look at this. Here is our keyword params. Params in int. And then you have your array here. You would say that this array is passed to this method as an argument. Okay? And here we have our for loop construction. But in the main body, what we have done is we've passed all these 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm counting with 0. So we pass all these 10 elements to our array. So show array now passes its elements or variables or values to array. So we pass this and they move in here, and from here they go in here. So basically this is how it works. First of all, goes from here, here, and then here. And then of course it gets printed out here. So if you run this program, what you should see is we'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 printed out. Let's run it and see. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically this is how we use params, and it is used to determine the parameter of the method that receives a variable number of arguments. So here this method is receiving a variable number of arguments. Argument 0, 1, 2, 3, 4. All these arguments can be passed straight in here, and then they will be processed in this for loop construction. And that's how we can use params. The next example is just a rule about how to use params. A parameter with the keyword params should be at the last position in the parameter list of a method. So here we have our method, which of course in its in its arguments we have a string name and we have our array here, and our array has the keyword params. So what this rule means is that this params has to be the last thing here. If I were to take this, let's run this program first. Is it working? Numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where did we get numbers from? Well, we got numbers from here, from our body. Okay, so here we are pushing in these arguments, we are passing them right in here to our array. We pass them right into our array, and you can see 1, 2, 3 arrays have been highlighted. So these are the same, these have the same. Now these, you can see our string here, numbers goes in here, and after this string we have a comma, which is this comma, and then we have 0 to 9, which is right in here, which is passed right in here, and then they are processed here in the loop. So what happens now if I remove this params? Let's see, will it work? No. Build errors. Okay. Let's close this. Take this back. Now it will work. Now we have params. Let's try it again. Params. But this rule says that params has to be here. What if I remove these params from here and take it, let's say, here? Oh, let's take this complete, let's take this complete part and put it right in here. And let's put our comma right in here and remove this comma so that you don't think I'm doing something. And let's see. You have build errors. So it will show you errors because a parameter array must be the last parameter in a formal parameter list. So what we are saying here is this params, it has to be here no matter what you do. Let me just return it back to its normal place. So now it has to be at the end. No matter what you do, it has to be at the end when you're using your params. And of course, your values will be passed into the array and it will be run. Let's run it now and see. It's working. So basically, this is a short explanation of how to use params and so on and so forth. Here, I think this is the last example in our explanation, in our practical part. So this marks the end of our first course, Starter Program. Thank you very much for your time and attention and your patience also. I hope you've learned something very useful here, and I'll also recommend that you try and practice everything we have done. Just play with all the variables, loops, conditionals, patterns, and so on and so forth, and see you in the next course.